Hello and welcome to my end of semester database systems final project. For my project, I built a database for the Paris Movie Theatre to help them better manage their records. Without wasting much time, let's dive right into it. So, the Paris Theatre is a theatre company with the main aim of providing the latest blockbuster cinema entertainment to its customers. Its main office can be located in Accra, Ghana, and appeals to a customer base of over 5,000 individuals. The theatre previews a distinct catalogue of recent and popular movies for its customers. These films are acquired through distribution companies on the basis of which films the company's executives and management teams feel will bring good ticket sales. The operations and structure of the theatre are as follows. The theatre's main customer segment is made up of middle and high income individuals between the ages of 5 to 50. Reservations can be made in person or online with a wide variety of payment methods being accepted. The company offers gift vouchers or discounts with tickets and snacks to customers frequently to improve customer retention. The business also has a food and snack bar functioning around the clock 7 days a week. Moving on to the reason for this project. The Paris Theatre has numerous customers with different movies showing at different times and venues. There are also a number of employees with varying skill sets. Initially, the theatre's records were kept track of using a file-based system. This led to inconsistencies in this reservation record and a lot of data dependence, as well as duplication. This made going about their daily operations difficult, and so they needed an efficient, centralized database system that can store their records pertaining to customers, distributors, employees, movies, and much more. This would improve their profitability and service capability. Moving on to the functionalities, management would like this design should enable management to get information on current ticket reservations, track seat assignments and availability in the various screening rooms, track which employees are assigned to which tasks in the screening rooms, keep track of movie in the inventory with upcoming showing dates and times, get information on the customers eligible for discounts and vouchers based on their number of visits, and track employees which handle which bookings in events where there are issues or inconsistencies. Moving on to the EAR diagram, we have about 6 strong entities and 10 weak entities. To begin with, we have payments which validates one or more reservations and a reservation being validated by exactly one payment. Also, a customer makes one or more reservations and a reservation belongs to exactly one customer. Reservation comes with 0 or more services and the service can belong to exactly one reservation. A reservation assigns exactly one seat and the seat can be assigned by 0 or more reservations. An employee handles 0 or more reservations and a reservation can be handled by exactly one employee. Also, an employee is assigned to 0 or more screening rooms and the screening room is assigned to by exactly one employee. An auditorium displays 0 or more screenings and a screening can be displayed by exactly one auditorium. A screening is exactly one movie and the movie can be 1 or more screenings. Um, a movie has exactly one license and the license belongs to exactly one movie. Also, a distributor provides one or more licenses, and by a license can only be provided by exactly one distributor. Over here, we have a decomposition of a many-to-many relationship. We have a screening displaying 0 or more screening advertisements, and the screening advertisement being displayed by exactly one screening. And an advertisement is exactly 0 or more screening advertisements. And by a screening advertisement can be exactly one advertisement. At the top here, we have generalization specialization structure where a payment can either be cash, mobile money, or card, and the relationship between them is mandatory or. Moving on, over here we have our entities and non-key attributes. So the strong entities are employee, customer, movie, auditorium, distributors, and advertisements with these non-key attributes. And the weak entities were reservation, seats, payments, services, screening, license, mobile money, card, cash, and screening advertisements with these non-key attributes. Some assumptions made in designing this database were not all screening display advertisements beforehand. A reservation can only be validated by one payment. Each reservation can only assign one seat. A payment can validate multiple reservations, and a screening is assigned to just one employee. The exact list of enterprise rules that the EAR diagrammatically represents have been listed out as follows. Moving on to the logical database design, we have the employee entity with this primary key being employee ID and the customer entity being this primary key being customer ID. With the license entity, there was a one-to-many binary relationship between distributor and license, with the parent entity being distributor. So the parent entity's primary key was posted inside the license entity. And since there's a one-to-one relationship between movie and license, these two tables were combined. With auditorium, the primary key was the auditorium number and services. The primary key was service ID, with the foreign key being reservation ID, due to the one-to-many binary relationship with mandatory participation between reservation and services. With distributors and suppliers, we had distribution ID being the primary key, and with reservations, we had reservation ID being the primary key, and employee ID, customer ID, seat number, and invoice number all being foreign keys, due to the one-to-many binary relationship with mandatory participation between reservation and each of these entities. Moving on to seats, the seat number was the primary key and screening ID was a foreign key because there was a one-to-many binary relationship with mandatory participation between seats and screening. With payments, the primary key is invoice number, and with screenings, the primary key is the screening ID, with the foreign keys being the auditorium number, movie ID, and employee ID. This was because there was a one-to-many binary relationship with mandatory participation between screening and each of these entities, and the foreign keys in these entities were the parent entity, so their primary keys were posted in here as foreign keys. Moving on to advertisements, the advertisement primary key is the advertisement ID, and with screening advertisements, the decomposed table. We have screening ID and advertisement ID being posted here as foreign keys, forming a composite primary key. With mobile money, the primary key was the invoice number, which is also a foreign key from the payment table since this is a specialized class. And with cash and card, the same was done here. Moving on to the SQL implementation of the work. The various tables were created with their various constraints. The auditorium table was created and the unique constraint was applied to the auditorium name to ensure that no two auditoriums have the same name. In the employee table, we have the unknown data type being used and the not null constraints on this field. The check constraint was also applied to check whether an email follows a particular pattern. Similar to the employee, the not null and email and check on the email constraints were applied. In the distributor table, the check constraint was also applied to check whether the email follows a particular pattern. And the movie table, the check constraint was applied to check whether the duration is greater than 0. In the screening table, the various referential integrity constraints were applied to the different foreign keys. And the advertisement table, we have the auto increment field. We only have auto increment on the advertisement ID field, and we have an unknown data type being used to represent the different advertisement formats, and the check constraints check whether the end date inputted is greater than the start date. In the seats table, a default value of 1 is used to indicate that a seat is available, and 0 is used to indicate that the seat is not available. In the reservation table, a default value of 0 is used to indicate that a ticket has not been picked up, and 1 to indicate that it has been picked up. In the cash, mobile money, and card table, the referential integrity constraints are applied on the foreign keys. Moving on to the indexes created. An index was created on the employee first name and last name. This was because lots of functionalities entail tracking employee-related tasks such as assignment to screenings and which employee aided which booking. So this index would help retrieve this information faster. Another index created was on the customer first name and last name, and this will help retrieve data around customer information and reservations quicker since this is a common query in the business. The next index created was on the seat number. And one of the functionalities listed out was to track seat availability and assignments, and this would help retrieve such data quicker. The last index created was on the auditorium name because this would help retrieve the auditorium employees are assigned to. The auditoriums which screenings are happening in or taking place in quicker, which is a common request in the theater. Moving on to the data population. Each strong entity was populated with at least 5 entities, and each weak entity populated with 10 entities. The insertions were as follows. Moving on to the queries used. The first query tracks the seat assignments for the different customers and the various screenings. When it's run, you see that it lists out the customer first name and last name, the movie name, the date the movie is screening, the time the movie is screening, and the seats the customer has been assigned to. The next query keeps track of which employees are assigned to which screening rooms and at what times. When the query is run, you see that it lists out the auditorium number, the auditorium name, the employee first name and last name, the date at which the employee is assigned to that screening room, and the time at which the screening time the screening time that the employee has been assigned to. The next query keeps track and manages movie inventory with showing dates and times. When it is run, you see that it lists out all the movies in the cinema's current catalog, and they are showing dates and times. Those that do not have showing dates and times appear as null, and the rest are indicated as such. It also indicates the description of the movie, the movie's rating, and as well as the duration of the movie. The next query gets information on the current ticket reservations. As you can see, when this is run, it lists out the customer's first name and last name, the movie that they have made a reservation for, the date they made the reservation, the time they made the reservation, and the actual date of the reservation and the actual time of the reservation. The next query involves getting information on which customers are eligible for discounted prices and vouchers. Discounted prices and vouchers apply after a customer makes 2 consecutive visits. So when this is run, it lists out the customer ID and the customer name of the customers that are eligible for these gifts and vouchers, and also shows the number of times they visited the theater. The last query involves keeping track of which employee aided which booking for events where there are issues, in case of events where there are issues or inconsistencies. When this query is run, it lists out the employee first name and last name, the reservation ID, the name of the customer in which the reservation was made for, the date of the reservation, and the time of the reservation. This brings me to the end of my demo. Thank you very much.